Given the function f of x equals the square root of the quantity x plus 2 minus 3, determine the domain and then graph the function. The domain is a set of all possible inputs or x values, and because we have a square root function, the function values are real only when the radicand, or in our case, x plus 2, is non-negative. This indicates to determine the domain, we need to solve the inequality x plus 2 greater than or equal to 0. To solve for x, we subtract 2 on both sides, which gives us x greater than or equal to negative 2, which is the domain expressed using an inequality. Let's also graph the domain on the number line. We would have a closed point on negative 2 and an arrow to the right, approaching positive infinity, which means we can also express the domain using interval notation, which would be the interval from negative 2 to infinity. The interval is closed on negative 2, or includes negative 2, and therefore we use a square bracket to the left of negative 2, and we use a parenthesis to the right. And now let's work on graphing f of x as a transformation of the basic square root function shown below. Any transformation of the basic square root function can be written in the form of f of x equals a times the square root of the product of b and the quantity x minus c plus d, where the values of a, b, c, and d indicate the type of transformation. Comparing this form to the given function, notice c equals negative 2, because x minus negative 2 simplifies to x plus 2. C equals negative 2 indicates a shift left 2 units. And we have d equals negative 3. D equals negative 3 indicates a shift down 3 units. Which means to graph the given function, we can use key points on the graph of the basic square root function shown below and shift each point left 2 units and down 3 units. For example, starting at the point 0, 0, if we move left 2 units and down 3 units, this point is on the graph of the given function f of x. The next key point is 1, 1. Starting at 1, 1, we move left 2 units and then down 3 units. This point is also on the graph of f of x. Starting at the point 4, 2, we move left 2 units, down 3 units. If we started at the point 9, 3, which is off the coordinate plane, but if we moved left 2 units, we would be at 7, 3, and then we'd move down 3 units to the point 7, 0. And now we have 4 points that we can use to graph the given function. This is the graph of the given function f of x, which is the graph of the basic square root function shifted left 2 units and down 3 units. Let's also verify this using Desmos. At the right, we have the graph of the basic square root function, and now I will change c to negative 2, which shifts the graph left 2 units, and then I'll change d to negative 3, which shifts the graph down 3 units. I hope you found this helpful.